Welcome back to another lecture on our LeetCode coding series. I'm Atul Kumar, and today we have an exciting problem to discuss called the three-sum problem. The problem is a variant of a famous two-sum problems, and it has been frequently asked in various coding interviews conducted by renowned companies such as Google, Adobe, Amazon, Apple, Facebook, and even Tesla. So you can see that it holds a great significance. So let's start with the problem statement. The three-sum problem involves finding all the unique triplets. What is a triplets? It's a basically combination of three numbers. And in that integer array. And what is the integer array? Here we have given as nums. Nums is our integer array. Where I, j and k are distinct indexes. And the triplet must satisfy two conditions. What are those two conditions? Simply, I not is equal to j, I not is equal to k, and j not is equal to k. All three indexes are different. Also, another condition is the sum of three numbers, that means nums of I, nums of j, and nums of k must be 0. That means equal to 0. So, for this problem, we have to first understand this by our example. By example 1, we have nums array, and here the outputs are simply -1, -1, 2, and -1, 0, 1. So why this is our output? So as we have discussed earlier, we have to find triplets where the sum of all the numbers becomes 0, should be 0. Okay, and also it must not contain any duplicate triplets. So if you see this example nums 1, so here, if we consider this triplets, it's also becomes 0. This is our first triplet. Also, you can see that this -1, this 2, and this -1 also makes another triplet. And if you consider this 0, then this 0, 1, and this -1 is also another triplet. Okay, same way, if we consider uh, this -1 as first, and again for this 0 and this 1. So in this way, we will find so many triplets whose sum becomes 0. So here, these are the possible triplets. And so you can ask me why this is the only output, like why this is -1, 1, 2, and -1, 0, 1. Why this is not 2 minus minus 1 and 0, 1, -1. So here, the thing is that the order of triplets does not matter. Okay, so it may be in any order. It may be 0, 1, -1 or -1, 0, 1. Okay, but the what matters basically, we don't have any duplicate triplets. It must have. Okay, so it must have unique. So here, let's see. Okay, so what are the things you can see here? These are the triplets where -1, 0, 1, 0, 1, -1, and this -1, 0, 1 are the same triplets. Why the same? Since their order are different, but they are same, so we can take any one triplet here. And also this -1, 2, -1, and -1, -1, 2 is same. Okay, so overall we have only two triplets, so sum equals to 0. So this is basically the problem statement. Okay, so now we have to solve this problem. Okay, so how can we solve this problem? Simply, uh, for any problem, if you want to solve any data structure algorithm problem, or if you want to solve any problem at computer programming, what you have to do, you have to break the problem into sub problems. Okay, so in this problem, what are the sub problems? So first thing is that we have to find triplets. Okay, first thing is that we have to find triplets. Another thing is that it must not contain any duplicate triplets. That means it should be unique. Okay, so these are the two phases of this problem. First we will find triplets, then we will find unique triplets. Okay,
So there are different approaches for this problem. So obviously we will start from brute force approach. Okay. So maybe your interval will not happy with this approach. But first we will solve with brute force approach, and after that we will further optimize it. But the idea behind this is very simple. You have to find triplets, and after that you have to go through 4 unique triplets. Okay. So here we will solve the first part. We have to only find all the triplets. Just think about the basic idea. What are the idea comes in your mind when you want to find triplets? So here you can see that you can make any combination. Okay, you can make any combination of elements. That means since you have to build the triplets, so it may be any 3 numbers in the array. Okay, any combination of array. How can you know that without uh, traversing each and every element? Okay, so maybe this -1 is 0, and this one is another triplet. Maybe this -1, 2, this -4 is a triplet. This 2 -1 and -4 is another triplet, and it is 0, 2, -1. So if you consider this -1 as the first place and this 0 as the second place in your triplet, then this 1, 2, -1, -4, any elements may be the third element in your triplets. Okay, so same way you will go for all the numbers and just simply check it if their sum is equal to 0 or not. And same way when you start with this 0, when you consider this 0 as your first number, then this 1 may be your second number, and this 2, -1 and -4, any of 3 number may be your third number of that triplet. Same way we will go for this 1, and after that we will obviously this 2 is your second number, and we will go for -1 and -4. Same way when you will go for the first number as uh, 2, then this -1 and -4. So what are you actually doing? You are making all possible combination of triplets. Okay, so all possible combination of the array numbers. So here, how can you do that? Uh, you simply use for loop. Okay, so since we are traversing the array and we are making a combination of 3 elements, and each element is one time combined with another element. Okay, so here you can start a for loop simply, and it may be start with any index value, sorry, any value. It may be I, j, k, anything. So you start from first index value, that is for -1. Obviously the next for loop simply start with j, it's I plus 1. That means you start a second element at uh, this position. Okay, so here uh, this is j. J is simply your I plus 1. Obviously you have to build a triplets, so the another for loop is simply start from here, that is from k plus 1, sorry, j plus 1, that is your k. So in this way you can make a possible 3 number combination of each array elements, okay, using 3 for loop. And here after that what you will do, you simply check if their sum equal to 0. If their sum equal to 0, and if their sum equal to 0, that means you find your triplets, and this is basically uh, your triplets. So in this way you solve the first part of the problem. You solve the first part of the problem. What is that? That is you solve the uh, problem like you have all the triplets whose sum equal to 0. Okay, so after that what you will do, we have to notice that uh, in this problem we have to only consider unique triplets. Okay, so you can see here in this problem statement, it is saying that uh, there obviously the sum of the triplets equal must be 0. Another part is that it must not contain any duplicate triplets. Okay, so here, so if we consider this example, okay, so here, so what are the triplets whose value becomes 0? So you can see that this minus 0 1 is one triplet, obviously this one, and again this one, this 0, this one, and this minus 1. So you can see that 1 0 1, okay, 1 0 1 minus 1 0 1 is one triplet. Simply you can say that 0 1 and minus 1, okay, 0 1 and minus 1. Same way 1, obviously minus 1 2 and minus 1, minus 1 2 and minus 1 is your another triplet. Also you can go for this value like minus 1 0, and this is 1, and same way this is 0 1 and minus 1. So these are the triplets whose sum is equal to 0, but we have to only consider the unique triplets. Okay, so here these two triplets are same, minus 1 0 1 and 0 1 minus 1. How can I avoid these duplicate triplets? So there are two things here. So in the second part you can notice that there are two things. First thing is that, and another thing, okay, so first thing is that we have to make sure the elements, okay, the array elements inside the triplet must be in same order. If this is minus 1 0 1 and another triplet is also minus 1 0 1, that means you can simply avoid the duplicates. But if the order is not same, then how can you avoid it? So either you have to sort it, okay, then you will avoid it. So the first part is that we have to make the order of triplet is same. Okay, we have to make sure the order is of triplet is same. Here the order means if the first triplet is minus 1 0 1, then another will also be in this same order, that means minus 1 0 1. Okay, so in this way, so here this is the first part of the second part. First we have to sort it, and the second part is that we simply avoid duplicates. So obviously we will use set data structure. Okay, so to avoid duplicates, so in this way we can simply get unique elements using set data structure. So there are two ways here to the first part of the second part, that means you want to make maintain order. So here one thing we can do this is we will sort the array initially. Okay, if we sort it, then you can notice that all the elements, like if there is a minus 1 here and it is here, so they will at the near place. Okay, so here what will be the triplets? It's simply minus 1 0 1, and again it is minus 1 0 1. Here you can see that this minus 1 0 1 and this minus 1 0 1 are in the same order if we sort it. Okay, and there this minus 1, this minus 1, and this 2. Okay, so they are in same order. If they are in same order, we we will simply use set data structure to avoid duplicates. Okay, that will be easy for us. So this is basically the first part of the second part of this problem. So why we sort the array. Another thing what you can do that, so another thing is that if we not sort it here, so here we will find the triplets. Okay, suppose we will get minus 1 0 1, and again we get 0 1 minus 1. Okay, so in that case we can simply sort only the triplets, the elements inside the triplets. That will be also fine, and after that we will use set data structure. Now you can see the brute force code here. So we have a the three sum problem function. Okay, and here we have to return list of integer. Obviously we have to store our triplets. So to return a data structure, we simply use a list of integer. And since we have to avoid duplicates, so I'm using a set data structure that is simply a set of list of integer. Okay, and here what we actually do, we first sort it. Okay, this part is basically the first part of the second part, and here you can see that the first for loop start from index 0. Another for loop is simply start from I plus 1, and the third for loop is simply start from j plus 1. Okay, so you are making a combination of three elements, and after that what you will do, you will simply check it if their sum is equal to 0 or not. So here we already sort it, so that's why I'm just adding the nums I, nums j, and nums k inside the set. Okay, uh, and here when we build our set, we simply add all the triplets inside the list and we return it. So this is the brute force algorithm, or you can say that the brute force approach of this the three sum problem. Now, the very important question: what is the time complexity and space complexity? Obviously, interviewer will not happy with this solution, but he can ask, explain me the time complexity. So you can see that I am sorting the array, so it is simply order of n log n, and after that I am using three for loop. So it is order of n cube. So here we are iterating from 0 to n minus 1, and each time we are going from 1 plus index to last index. So in this way, in the worst case we go order of n cube. Okay, and since we going to use upper hand, so we avoid this n log n, so we can say that the time complexity is order of n cube. But here you can think that what is the space complexity. So why I'm writing here order of k, and what is k here. So at a particular time, what you actually doing, so you only store the unique triplets inside the set. Okay, so here k is the total number of unique triplets. That is basically our space complexity order of k. Hope you understand this brute force approach. Okay, now we're gonna solve this problem using a better approach. We're gonna use the help of two sum problem, and also we will discuss two pointer approach. We don't need to use three for loop. We can solve this problem with the help of two for loop also. Okay, so let's see solve this problem using better approach. Okay, so here's the better solution. We optimize the time complexity from order of nq to order of n square. Let's see how. So since in the previous approach, we have to iterate through all the array elements. Okay, so since we are finding three numbers, first nums of I, second is nums of j, and third is nums of k. Okay, so that's why we have to use three for loop. So think, if we only have these two numbers. Okay, so if we only have these two numbers, first numbers is nums of I and second is nums of j, and anyhow we don't know right now, anyhow can we get this nums of k. Okay, so if we can do this, we can only use two for loop. Okay, this is the first part. So how can we get nums of k? We simply calculate it at this way. Nums of k is basically minus of sum of previous two numbers. Now this is your two sum problem. Okay, the variant of a two sum problem. This is the first part. We can easily get the third number. Now let's see the second part. Now we have to iterating the value nums of I and nums of j. So for that we have to use two for loop. Okay, so we have to use two for loop. Okay, so 1 minute guys. So we have to use two for loop here. First for loop for nums of I, and another for loop for nums of k. Since we have to make all the possible combination of nums of I and nums of j. Okay, and here this is our two for loop. So think in this way. So we have to use 2 for loop. That's why we can solve this problem in order of n square. Now you can ask me, okay, we are iterating the elements, understood. We have nums of I, nums of j. Now, how can we solve this problem? Again, let's talk about the third step. So suppose uh, here there are any two combination of numbers becomes our nums of I and nums of j. So I am considering this value as our nums of I, and this value is our nums of j. So think about this situation here. So any value. So we already occupied two numbers. First number as -4 and second number as our 2. So what will are the third number? So any value between them. Okay, this value. You can say that this value. Any value between -4 and 2 will be our third number. Okay, we don't know that number right now, but that will be our third number. That will be our nums of k. Is that any? So so here is the fourth step. What is that fourth step? Is simply if we suppose find first two numbers, nums of I and nums of j, then we can get the third number. And what is that third number? It must be between the first two numbers, that is nums of I and nums of j. So the fourth step is that we have to search, is that any element between that is our third number. So suppose somehow we can get that any value between them is our third number. So here this is +2. Okay, this +2 is our third number. So we can say that here this 2 is our third number. So this 2 is between these first two elements, -4 and 2. Okay, so right now first thing is that we have to store the elements between these first two element, this -4. We have to first store the element with this -4 and 2. Okay, the all the between elements between them inside any data structures. Okay, so and after we have to search the element, we have to search the third element uh, between them. Okay, so we can use array list, or obviously or obviously the better data structure has it. Okay, so here we can use anything. After that we have to search the third number in that group of element -201. So since the contains method inside the hash set data structure, you can say that in Java, if you use hash set instead of tree set, it will take order of one time. If you use tree set, it will take order of log n time. Since we have to maintain the time complexity in order of n square, we are already using 2 for loop. So here time complexity is already order of n square. So if you further take order of obviously any time complexity greater than order of 1, it will be not our order of n square, it will be greater than order of n square. So but we have to solve this problem in order of n square, so we are using here hash set. Okay, so we are using a set data structure storing these elements which is between these two elements -4 and 2. So here this is the fourth step, so we are using a hash set. Okay, and we will put that element, all the elements, that is -1, obviously 2, okay, and 0 and 1. So these are the elements between this element. We have first element as -4 and second element is 2. So we have to find is that any value which is our third element inside the set. Yes, here I find it. So we can easily get our triplets as -4, okay, and 2, sorry, and 2. This is our triplet, we find it. This is the process. Okay, so this is the process we can solve this problem is order n square. But very important question, we have a, you can say, roughly idea how can we solve this problem, but we can ask me, how can you store the data inside the set to make sure that all the elements, okay, all the elements between first two elements, that is our nums of I and nums of j, will be inside the set. Okay, that is very important question. So this is the fifth part, you can say that. So for that, let's understand in this way. So since I'm using two for loop, so obviously the first for loop is uh, iterating the index value I, and second for loop is basically I plus 1. We will start from I plus 1. So this is our second for loop. It will iterate for all the value. So initially we have the index value 0. Okay, and for j it is I plus 1. So we have start from this index value. So right now you're gonna add these two numbers, first numbers and second numbers. It will become minus of 5, and what will be our third number? It is basically plus of 5. When you calculate this, plus of 5. So here what you will do, you will check if that any is that any value between them. So how can you know that? So for that, what we actually do, we will simply use that set. We can say that is that any value inside the set. So here our set is empty, we didn't put any value inside the set. Okay, this is another thing. We can break this part into two parts. First thing is that we can check inside the set, is that any value inside the set. And you can again ask me, how can you put the value inside the set? So here I'm just checking that is that 5 value plus 5 value inside the set. No, there is no in plus 5 set, because initially set is empty, we didn't put any value inside the set. Okay, no. So what you will do, you will simply put this value, this minus 1, inside the set. Okay, so in this way you can put the value inside the set, and this is our nums of j, this is our second value. And but you can say that if you are here, okay, when your j index is here, so at that time this second value will become your third value. That is, the nums of j will become nums of k for that index, okay, for the next index. So here, when you will do the same process, minus 4 and plus 2, you will become minus 2 and you will get plus 2. Okay, so you will find, is that any plus 2 inside the set? No, there is no any plus 2. But uh, here what you have to do, you have to put this plus 2 inside this set. Okay, this is the process. You can easily see that we are storing the elements, okay, between the two values, between the first two values inside the set. So again here, what you will do, you will go for the next index value 0, and simply you will add it, you will get minus 4, and after that it will plus 4. So you will check that is that any plus 4 inside the set? No. So what you will do, you have to also put 0 inside this set. Now you are at this index value 1, we again add it, it becomes minus 4 and 1. And here you will get that this is minus 3, and after calculating it, you will get plus 3. The third value is plus 3. You can check, is that any plus 3 between them? No. So you have to put this one also inside the set. Now you are at this index. Now you come here. Okay, so you are at this place that you are storing all these elements inside your set. Okay, so uh, this is our fifth part. How can you store the data inside the set to make sure that all the elements between them, nums of j and nums of this second, will be inside inside the set. So now you will repeat the process. You add this and you will check, is that any set inside this or not. Sorry, element is that or not. So minus 4 plus 2, obviously minus 2, and your third number is plus 2. So here you will simply check it, and your set using a contains method in order of one time will say you this 2 is inside this set, and you will get your triplets minus 4 comma 2 comma 2. Okay, this is the overall approach of this problem, and now you will see how can we write the code, and also when I will explain the code you will understand totally easy way. Okay, so let's see. So how can you write the code? So uh, we have to first sort the array. You know already why we have to sort it, because in the previous approach I already told you that we have to maintain the same order of triplets. After that we can easily find unique duplicates, sorry, unique triplets. That's why we have to sort it. So
After that, we have to use a list of integers simply to return the triplets, and that then after I'm using a set of list of integer is basically here. It is using basically to avoid triplets. Okay, and you are already familiar with this set, what we actually discussed earlier. This set of integer basically used to store all the elements between the first two elements, nums of I and nums of j. Okay, so this set is nothing but this is our set 2, and it is basically used for to storing the third elements. Okay, and after that we have to use two for loop to iterate the array elements, since we have to know at least two elements, nums of I and nums of j, that is the first two elements, and we have to make the possible combination of these two. Okay, so we have to use two for loop, and we are starting the index value from 0, and here we are increasing the index value of second for loop I plus 1. Again, you can see that why I'm using a set here. It basically tells that for every iteration, okay, for the every second for loop, we are using another set. Another set means another possible combination. Okay, so here I'm just gonna erase this. Okay, so this is the scenario. This is a set basically used for this minus 4 and this 2. Okay, and think if you have only this number 1 and 1, this is your nums of I and this 1 is your nums of j, that is this is your second element. So there what you will do, you will simply put uh, value 2 and 0. Okay, this is the set elements. Okay, this is the array elements inside the set. So this is another set. Also, you can see that the array elements between the first two elements are different. So for this minus 1 and this one, this is our set. This minus 4 and this is 2, this is our set. Okay, so why? Because this is the only elements between them. Okay, if we consider this as an array, so these two zero are the only elements between them. So that's why we have to use another set. Okay, so we have to use a set for every iteration. Okay, we have to use a set for every iteration, for every index value of I, you can say that. So I'm declaring here and giving the memory here. So this is the second for loop, basically to iterate j index j, obviously the index value j. And now understand the important part. This is our formula which we already discussed. Okay, the data, what that is nums of k, we simply calculate it. And after that, here I'm using the set data structure, which usually check is that any third value inside a set or not. So since we am using hash set, so it will take order of on one time the contains method to find that the third element inside a set. And if that third element is present inside the set, we simply make it as a triplet. Okay, so we simply make it as triplet, and here we simply add inside this first set, which is used to basically to avoid duplicates. That's why I'm using this first set here, and this is basically use array dot as list to make it as list, like means it is used to make this array elements into a list, and after that we can add inside this set. Okay, and here suppose if that element, the third element, is not present inside the set, so at that time what you will do, you will simply put the second element, okay, inside the set. In the second set, you simply put nums of j value inside the set, the second element. So we are doing the same here. And after all this, you have duplicate triplets inside this first set, and now you have to return list of integers. So that's why you add all the elements of that set inside the list and simply return the list. Okay, this is basically our solution. Listen carefully. There are two things. First thing is that you are good in problem solving, and second thing is that you have to also good in implementation. This is basically the implementation. You have to know how to use the data structure, which data structure should I use, and if you know how to solve the problems but you cannot able to write the code, that means your implementation is weak. So do practice. Okay, both things will be good. And right now you can ask me what is time complexity and space complexity. So here you can see that we first sort the array. So simply it will take n of log n time, order of n log of n time, and here I'm using two for loop. Okay, and that's why it is taking order of n square. And also here this contains method is simply using order of one time. But if we use a tree set instead of hash set, that will become our order set, so it will take order of log n time. In that scenario, the time complexity become order of n square multiply with order of log n, okay, into log n and plus of n log n. Okay, so if you are using order set, it will be the, you can say that if you only consider the upper hand, it will be order of n square into log n. But here I'm using a hash set. It will only take order of one time. So you can say that order of n square multiply with one. Okay, order of one. Sorry. So here we will consider this upper hand. So you can say that the overall time complexity of this approach is order of n square. Now you can ask me what is the space complexity. So that is also very important question, because in the next approach we will solve this problem in order of one space complexity. So here we are using a set and a list of integer and a set of integer. Okay, so this set of list of integer, the first set is basically used to store duplicates. So which is order of k time. We take order of k space. Okay, so where k is the number of unique triplets. And since we are using a list of integer to return the value, so that's why it will take again order of k time this list of list. So we simply multiply its order of k multiply with 2 times order of k. And right now this set, this our set, the second set, this set, how much time complex, sorry, space complexity it will take. So think about the situation, the previous situation we have already discussed. In the worst case scenario, okay, the set has to store the elements up to n minus 1. Okay, from, okay, total elements of n minus 1 of elements. It can maybe, it may be store minus 1 2 0 1 2 and this 2 also. Okay, so we can roughly say that order of n. So in the worst case scenario it will take order of n. So overall, sorry, the space complexity, so the overall space complexity is order of n plus order k multiply by 2. This is our uh, second approach, a better solution than a brute force approach. Now we will solve this problem using optimal approach, optimal solution. We will see the optimal solution using a two pointer approach. Okay, two pointer approach is very interesting. Also we will not use any hash set or any kind of data structure. You can, if you solve two sum problem of second two sum twos, the second variant, you can see there how you use two pointer approach. Okay, so let's see the optimal solution. Okay, so we have nums of I, nums of j, and nums of k. So in this sorted array, so any three value will be our triplets. Okay, so right now what I'm actually doing, so suppose this is our first array elements. So here this is our first array elements, which is nums of I. So ith pointer is here. Okay, and we gonna choose this array elements is our second element. Okay, that is nums of j, and we're gonna use this elements as our nums of k. So here this is a k pointer here. So what we actually want, we want our triplets. That is very simple. So why I'm gonna fix this pointer. Okay, so I'm gonna fix this pointer, that means this I pointer, and
these are the rest elements of the array. These are the rest elements of the array. And from that element, we have to choose any two elements which makes our triplets. Okay, so since we have a fixed one number and we have to find other two numbers. So how can we do that? Obviously, if we start a first pointer, okay, the nums of j from very beginning, so we're gonna move in this direction, and we have second pointer, that is k, at very last, so we have to move in this direction. So where we will stop if j will cross the k. Okay, so here this is our the base condition, you can say that this is our the termination condition. So where if j is less than k, if j is less than k, it is fine. Okay, if j is less than k, it is fine. If j greater than equal to k, that is basically there we have to stop it. Okay, so this is our condition. Right now, so in that way we can explore all their elements. Okay, now you're gonna ask me, okay, it is fine, we're gonna explore all the elements. Now what we will do after that? So here, see, in this way we have nums of I. Okay, we have nums of j, and we have nums of k. Okay, so here I is fixed and j and k is moving. J is moving right and k is moving left. Okay, simply. So here think if this is -4, and right now what is j is -2. So I'm just gonna simply put it -2 and k is 4. So what is their sum? So -4 -2 it's obviously -6, and their sum is less than, it's -2. Okay, which is less than 0, which is less than 0. Since we have to explore all the array elements, and array is sorted. Okay, array is sorted, so which is less than 0. So we have to know that which pointer we have to move. Either we have to move j, and either we have to move k, because I is fixed here. Okay, so here we got the value less than 0. This is the first condition, this is the first situation, you can say that the sum value is less than 0. And what are the other situation? Maybe there is a case where some value will be greater than 0. Okay, so these are the two possible cases. And the third situation is that the sum is equal to 0. If the sum is equal to 0, that will, there I will, we will find our triplets. So if think about the first situation, if their sum is less than 0, that means what? So this -4 is fixed. Okay, so we have two value, we have two pointers, this is our j and this is our k. So this is a larger value. Obviously we cannot further increase it because we already choose the last value, and since the array is sorted, so this is the largest number, so we can decrease this. Think about situation, if we further decrease this 4, okay, so after that can we reach at 0? No. If we further decrease it, then we will again gain the negative value, the more negative value. Okay, so but we have to go, we have to reach at 0. We have to, so what we want, we actually want more positive value or less negative value. So but we can simply increase this lesser value. So right now our j pointer is here, and we simply increase the this pointer j. Okay, but think about situation, when we increase this pointer j, we will get the same value. So if we have same value, the scenario is same, so it will not work for us. So what we will do, we will simply avoid this duplicate. So for that we simply increase the j value. Okay, so we reach at here. So here what we found that the new value is -1. The new value is -1. Okay, now let's see, is that sum is equal to 0 or greater than 0 or less than 0? So simply it is still less than 0. This is again the case scenario. And right now we have -1. So this is still less than 0. Now what you will do, you will simply increase the j index. j pointer, you can say that. So it is 0 right now. So if it is 0, okay, if it is 0, now see what is the triplet sum. So here minus 4, 0 and 4, obviously it is 0. So now you are at this situation. You are at this situation. You find your triplets. Okay. So what is that? First one is minus 404. This is your first triplet. Minus 4, 0 and 4. So this is your triplet. You find it. Now you're going to ask me what we will do after that. So if you find our triplets. So you are here. Okay. And your k pointer is here. That means there are so many elements between them. Okay. So maybe there is a case there may be a scenario where we will find another two elements which form triplets. Okay, so suppose think if there is a minus 2 and plus 2 here, that will also our triplets. So what you will do, you will simply move. So you find your triplet right now, then what you will do, you simply increase the j pointer. Okay, so here you find your triplet. So here right now you increase your j pointer. Okay, now you can ask me, do we need to decrease this k pointer also? So I will say you yes. Why? So we have only three elements. Okay, first one is fixed. If you fix the second one, it will never be zero again. Okay, so you have to move this two pointers also. You have to move this k pointer also. Move means like you have to decrease the k index since you are moving left. Okay, and in this way you can avoid duplicate triplets. Okay, this is the first way to avoid duplicate triplets. And what is the second way? So here the second way is, if you will get same elements, so simply we will simply decrease the k pointer or increase the j pointer. So here in this situation you can say that you again gain the value, you again get the value 4, and it will give you same duplicates. So for that you have to again decrease the value of k pointer, and this is same the case for this j. So you have to increase the j. Okay, so since we are not using this one yet, so right now you are at here. So what we will the sum here, this is 1 and this is 2. So here it is still less than 0. So what you will do, you have to increase the j index. So right now you are here. So this is the same value. So you have to avoid it and you have to increase the j value. So you are here. Now your j and your k is at the same value. That means this is not the situation here. J less than k. Okay. So here we have to stop because we explore all the array elements. Okay. We explore all the rest of array elements. And here we find our triplets. So in that case, what you will do? Now you're gonna increase this index I, this fixed value. Now you are here, minus 2. And you will repeat the process from this index and this index. So here what you will do, you will do the same process. Okay, suppose there is a situation where their sum is greater than 0. What you will do, we will do the same thing. If the sum is greater than 0, that means we have to simply decrease this value. Okay, so if this value is lesser, we gonna reach at the 0. Our main goal is to find the triplets whose sum is equal to 0, equivalent to 0. So where we are close to 0, if we move a j pointer, that means the lower value pointers, that means uh, if the value is negative, then simply we will move j pointer. If the value is greater than 0, we simply decrease the k pointer. This is the situation here. And another thing is that if you find your triplets, what you will do, you have to move both the pointers. Why? Because we have to avoid duplicate triplets. Okay, and another thing is that maybe they are repeating elements, we have to also avoid it. Okay, so this is basically two point approach. Let's see the code. It is very simple. First we have to sort the array elements. Okay, that is the basic key. basic idea. Okay, the most important part of this problem, we have to sort it. And here you can see that this is our list of integer. So we have to simply return that list, and I'm using two for loop. Okay, so first for loop is controlling the ith pointer, which is fixed for both the j and k. Okay, and here this is our second for loop, and this for loop basically controls two pointers, for j and k. Here our j is basically I plus 1, and k is simply the last value, that is num stop length minus of 1. Okay, so this is the condition, guys. J less than k. Okay, this is very important. You have to understand it, you have to know it, why j less than k. So I'll really discuss why j less than k. Okay, so here this is our termination condition. Okay, so you can ask me why I'm using this if I greater than 0 and nums of I is equal to num of I minus 1. So simply we have to avoid duplicates. There are two kind of duplicates here. First one is repeating elements. So in this way we can simply avoid repeating elements. So if there is minus 4, minus 4, minus 4, minus 4, so why we gonna start from the first minus 4? We will start from this. Okay, so last of minus 4. So for that we simply write if I greater than 0. Okay, this is the first condition. If it will not, this would be the since if it is 0, then nums of I minus 1 will give you a error. So it will give you a problem, out of index something kind of error. So why I'm using I greater than 0. And if you find any repeating elements, you will simply avoid it. That's why I'm writing poor duplicates. Okay, so we have to only choose one element. So we're gonna avoid other duplicates, and those are duplicates we're gonna call it poor duplicates, and simply continue it. So it will again go for the next index. Okay, right now suppose okay, now you're gonna move j pointer, k pointer. J will move forward and k will move backward. So here if you find your triplets, nums of I, nums of j, and nums of k, what you will do, you will simply add the triplet inside the list. Okay, you will simply add the triplets inside the list. So this kind of situation, you simply add the triplets in the list, and what you will do, you will decrease. Okay, so you will increase the j pointer and decrease the k pointer. Why? I already discussed, to avoid the duplicate triplets. So here I am writing j plus plus and k minus minus. Okay, this is basically where we find our triplet. So after that, these are the two things. One is because in every situation we find subs we can see that we have duplicate elements. Okay, so for that we have to simply avoid repeated elements. So in this way, nums of j if equal to nums of j minus minus, we simply increase j pointer, and here also we simply decrease k pointer. Okay, nums of k is equal to nums of k plus 1, and this is basically the important condition. Okay, if we cross this, then we will not go for the next part or next element. Okay, so these things uh, basically for avoiding poor duplicates. So after that, this is the case, this is the important part of this problem. If their sum is equal to, sorry, if their sum is greater than 0, so what you will do? If their sum is greater than 0, you will simply decrease this pointer, this k pointer. Okay, so you have to go for the lesser value to make sure that you will get your sum equal to 0. Okay, so that's why we have to decrease this k pointer. Otherwise what you will do, you will simply increase the j pointer. Okay, this is the overall situation here. This is the logic of this two pointer approach. Here I'm not using any extra data structure. This is simply a list of integers. So simply return the array, return the triplets. So here this is the return list. Okay, so this is not list, it's list of list. So I'm writing again LL. Okay, return list. I will simply add it. So this is basically our two pointer approach code. Hope you understand it. Now you can ask me what is the time complexity. So what we will do, we sort the array. So it is simply order of n log n. Okay, so n log n plus this, since we have to iterate all the array elements, we have to fix the first pointer. It is nums of length minus of 2. Okay, and why nums of length minus of 2? Because after that you will get other two elements, and here, so it is obviously taking order of n square plus n log n, so we will take upper hand, so it is obviously order of n square. So right now you can see that I am not using any extra data structure like hash set, or you can say any array list. So it is order of 1. We will not consider this list of integer. Why? Because we have to simply return it. So in that situation it is order of k, and k becomes our unique triplets. Hope you understand this problem, and if you really like this video you can share with your friends, and if you have any kind of problem you can simply write in a comment section. Okay, thanks for watching.